You always hear that AI is powered by just massive amounts of data. But what if I told you the real secret to truly powerful AI isn't just the data itself? What if it's a hidden process, almost an art form, that most of us never even see? Well, let's pull back the curtain.
And that brings us to a really great question, right? I mean, if these models can create unbelievable images from a sentence and write entire chunks of code, why do they kind of fall apart when you show them the raw, messy, jumbled data from the real world? The answer? Well, it gets right to the very core of how machines actually think.
And yeah, this slide just lays it all out perfectly. Over on the left, that's the world we live in. That's our data. It's chaotic, it's a mix of words and numbers and who knows what else. But on the right, that's what the AI model actually needs. A perfectly clean, perfectly organized numerical grid. There is a massive gap between these two, and the bridge that connects them, that's the secret ingredient we're talking about today.
That bridge has a name. It's called feature engineering. This is all the critical, often completely invisible work that happens before you even think about training a model. Honestly, you should think of it less like a science and more like human artistry and intuition meeting the machine.
So what is it technically? Well, it's the process of grabbing all that raw data and transforming it into clean, well-aligned features that a model can actually use. To put it simply, you're a translator. You're taking the messy language of the real world and translating it into the clean, structured language of a machine.
I absolutely love this analogy. Think about it. An AI model is like a world-class chef. This chef can make an incredible 5-star meal, but only if the ingredients are prepped perfectly. You can't just hand Gordon Ramsay a live cow and expect a steak. No way. Feature engineering is that prep work. It's the chopping, the cleaning, the dicing, the seasoning. It's what turns raw potential into gourmet fuel for the AI. And all this prep work in our data kitchen really boils down to two main things. First, there's feature transformation. That's all about creating new and better ingredients. And second, there's feature selection. This is about being picky, choosing only the very best ingredients and throwing out the junk. So let's break them both down. Okay, let's dive into that first part of our data prep. We're starting with feature transformation. This is where we go from having good ingredients to having truly great ones.
So the first technique here is something called feature construction. And this isn't about going out and finding new data. It's about being clever and creative with the data you already have. You're literally constructing brand new features that are way more powerful than the original parts they came from. Okay, check this out. Let's say we have this simple real estate data. We're trying to predict the price of an apartment. And we've got two pieces of info, the apartment's length and its breadth. Now, a model could probably find some kind of pattern here, but these two features on their own aren't super direct, are they?
So you have to ask yourself, how can we make this better? If you saw the length and breadth of a room, what's the very first thing your brain would do to understand its size? We can definitely build something way more useful here.
Of course, you'd multiply them to get the area, right? And just like that, boom, we've done feature construction. This new feature, apartment_area, captures the information from the other two in a way that's so much more direct and meaningful for predicting the price. We literally just created a better ingredient for our chef.
All right, so that was construction, building something new. The other side of this transformation coin is feature extraction. Now, if construction is about combining features, extraction is about distilling them, boiling them down to their purest essence and getting rid of all the noise.
So imagine you've got features like a person's height, their weight, and their arm span. They're all kind of related, right? They carry overlapping information. Well, with feature extraction, we can boil all of that down into a couple of really clear, powerful ideas. We can distill those noisy features into new, core concepts like overall body size or limb proportions. It just gives the model a much cleaner signal to learn from. Okay, so our ingredients are prepped. They've been constructed, they've been distilled, they're super high quality. But, a great chef doesn't just throw everything they prepped into the pot. Now comes the hard part, choosing only the best of the best. It's time for feature selection. And the whole philosophy here is just so simple. More is not better. In fact, sometimes more is just more noise. The goal is to find the absolute smallest set of features that gives you the most meaningful information. This makes your model faster, way more efficient, and, believe it or not, often more accurate. So what are we trying to get rid of? Basically two things. First, irrelevant features. This example is perfect.
A student's roll number has absolutely zero to do with their weight. It's pure noise. Get rid of it. And second, we toss out redundant features. Like, if you have age and years of experience, they probably tell a very similar story. You might only need one.
So how do you actually do this? Well, there are basically two main schools of thought. The filter approach is the quick and dirty way. It uses stats to score your features before the model even sees them. It's fast. Then there's the wrapper approach. It's slower, for sure, but it's often way more powerful because it actually uses the AI model itself to test out different combinations of features to see which ones work best. It's that classic trade-off, speed versus performance.
All right, let's pull all these threads together. We've taken our raw ingredients, we've prepped them, transformed them, and then we picked out only the very best ones. We've basically just uncovered the real secret behind great AI.
So, what are the big takeaways here? First, and most importantly, raw data is never ever plug and play. You can't just dump it into an AI. Second, by transforming our data, we can literally create more powerful, more intuitive features. Third, by carefully selecting those features, we cut out all the noise and junk that can confuse the model. And maybe the coolest part? This whole process, this is where human insight, our creativity, gets to guide the machine. It's a true partnership.
And that leaves us with this final thought. We've all heard that saying, right? Data is the new oil. But crude oil straight out of the ground, it's pretty useless. It has to go to a refinery to become gasoline, to become fuel. So if data really is the new oil, then isn't feature engineering the refinery, the absolutely essential and so often overlooked process that turns all that raw potential into the high-octane fuel that truly powers artificial intelligence?